My name is Anders Sandholm. I'm a member of the Chrome team, and so is Pavel Feldman, who will join me in a bit in talking about Chrome developer tools. We're both very excited to be here and to be able to talk about some of the work we've been doing over the past year. And in fact, we came here all the way from Europe to be with you today to talk about this. We'll go through some of the new exciting features in the Chrome developer tools. Just before we get started, I wanted to get a feel for to what extent we're barking up the wrong tree. So amongst you, when you're developing web apps, just let me see like a show of hands. How many of you are using Firebug on a regular basis for doing that? Okay, so that's a fair share. How many of you know Web Inspector and Chrome developer tools? Yeah. How many of you use it on a regular basis when debugging web apps? Yeah, okay, so it's okay. So if nothing else, I hope that at least after this session you'll have seen some exciting features in Chrome developer tools, and maybe want to try it out and give it a spin. One more thing before we get started. As you can see at the bottom of the screen, there's a link. You might want to note that down. There'll be live notes, and you can ask questions for this session. It's a wave that's specific to this session. Also, at the end, obviously, we'll have some time for questions, and we'll take questions here from the audience as well. Right. So let me talk a little bit about what we're going to cover in the session. Essentially, this is going to be about tools that you can use for debugging and optimizing your web apps. The structure is as follows. I'll talk a bit about what Chrome Developer Tools is and give you a bit of a brief background of the history of the project, what we've been doing over the past year or so. And then I'll pass on the word to Pavel, who'll talk in more detail about the tools itself, a quick walkthrough of the panels or the overall features available in the tool, and then after that, a few developer stories, if you want, or issues that we think you'll find familiar if you've been developing web services, and we'll show how the developer tools in Chrome can help you or support you in those tasks. If time permits, we can cover a little bit also the internal design of DevTools, and then obviously at the end we'll have time for questions. So again, as you've guessed maybe from the title or from the questions I asked before, if you think about what Chrome Developer Tools is, or what this session is going to be about, it is, you can think of it essentially, since so many of you know and use Firebug, you can think of it essentially as Chrome DevTools being to Chrome what Firebug is to Firefox. It's not a port of Firebug, but rather something based on the Web Inspector and WebKit. It is not something you have to download if you're using Chrome. It's part of the standard Chrome distribution, so it's right there, and you can use it with the browser. And one way to think about it, if you're familiar with the inspector, is essentially it's the web inspector running with the JavaScript engine specific to Chrome, namely V8, underneath. Plus supporting Chrome's multiprocess architecture. This allows us to develop new features so that they'll be available in all WebKit browsers, or in some cases where we're utilizing features that are specific to V8, we've been able to launch features that are available as part of the inspector, but for a start may only be available in Chrome. Right, so let me continue with a brief background of the history of the DevTools in Chrome. So essentially, Chrome launched a little over, or about a year and a half ago, And at the very beginning, there was only rudimentary support for developers. There was basically a command line debugger and the ability to do some inspection of the DOM. And what I wanted to show with this page is essentially two things. What you see in each line is a panel, so you can think of that as a group of features available in the tool. And as you can see, with newer Chrome releases, we keep adding more stuff, and the panels are mentioned again because we actually keep improving on the stuff that's already in there as well. The major thing happened about a year ago. If you look at the first release, which is the first Chrome version, there was rudimentary support. Chrome 2 is not even mentioned because somewhere between Chrome 2 and 3 is when Pavel and his team got started actively working on this out of our St. Petersburg office. And that meant that with Chrome 3 and onwards, we've been able to keep adding new features so that we are where we are today. And in fact, some of the later features that were added, Pavel is going to talk about in more detail and how they'll be useful in your daily work, hopefully. So with that, over to you, Pavel, to talk more about the actual tool.
Okay, thank you, Anders. My name is Pavel Feldman, and I'm a software engineer working on Chrome Developer Tools and WebKit Web Inspector. Today, I'll be doing a quick overview of the Chrome Developer Tools functionality for you and continue it with a number of developer stories that I'm sure you'll find interesting. During these stories, I'll show you some previews of new features that we've recently added in the Chrome Developer Tools. But before we go there, I want to mention that since Chrome Developer Tools is heavily based on WebKit Web Inspector, it's essentially a single source. Everything I'm going to talk about is available in any WebKit-based browser that has Developer Tools enabled. However, the developer stories I'm going to talk about are full of the functionality that is based on the V8 engine capabilities that are not necessarily there in other JavaScript engines. So that functionality will only be available in Chrome, at least for now. I won't have too much slides for you today, so it'll be all live demos pretty much. So the developer tools overview is just to walk through the existing panels and the perspectives of the developer tools. And the stories are the real stories about debugging of your JavaScript applications, memory profiling them, performance profiling them. With that, let me actually switch to a running Chrome instance. And I'm running a Chrome full screen here. Let me start with bringing the developer tools on the screen. So I'm using shortcut Command-Option-I on Mac or Control-Shift-I on Windows and Linux. And here it is. The developer tools window is opened in the docked mode. Let me undock it. So I'm using a status bar button to undock it. Here it is. Now we start with the Elements panel. That's the first in a row. And the Elements panel is where you spend your time designing your app visually, tweaking its layout, its style, working with the CSS, with the DOM nodes. You can see that the big part of a screen is a DOM tree, and this DOM tree is in fact live. So whenever document object model of your web page is changing, these changes are reflected on the screen. Now we can not only traverse through the elements here, you could mutate your DOM. I can double click to edit attributes. I can tap through them. I can tap to create a new element, a new attribute placeholder. I can even rename the tag name. I can also use context menu to edit as HTML. And editing as HTML is as flexible as it could be. So you can add tags there, you could paste arbitrary HTML snippets there, do whatever you want. Now for each of these nodes, we have a number of properties inspected to the right. What are these? These are the computed style. And the computed style is a number of styles as the rendering engine perceives it. So that's how it is going to render your element. Now that one is read-only. Then there is a styles pane, and the styles pane is a number of styles that are applied to your element as they are defined in the model, in the DOM model. Now, it contains the element style attributes or width and height attributes, as well as matched CSS rules based on the selectors here. Some styles inherited from the container elements, such as font size and font family, and the pseudo element styles that are missing on this page. Now, this one is editable. So you can double-click to edit the style. Also, I can traverse using tab key. I can create new ones using tab key. I can double-click an empty space to create a new property. And I can also edit the selector itself so that I make the rule applicable to more or less elements. Now, it's a Google.com page, so it's highly optimized. So all of the styles are inline. But in case they are defined in a separate CSS file, you'll have a link here navigating to a particular resource, to the CSS source itself. Now, this next one is the metrics, and that's the box model for your element. It shows you the dimensions of the element, as well as padding, margins, and borders. This thing is editable. Double-click and edit it. We have properties. For DOM elements, well, in fact, DOM elements have JavaScript wrappers, and that's actually how you talk to the DOM elements from your JavaScript world. And these JavaScript wrappers are just JavaScript objects, so you can put arbitrary properties to those, and that's the place to inspect them. So we have all the JavaScript properties in here. You can expand them and explore more. You see the nice prototype chain of the select div element, so that you can track the inheritance here. And the last one is the element listeners, and let me show you what it does. I'm docking it back, and I'm using an inspect tool to inspect the search field. Now you can see that there are 3 types of event listeners registered to that field. So we've got 2 blur listeners, 1 key down, and a key up. Now for each of those, I can navigate to a source where handler is located. Well, Google.com is minified, so you won't see anything good here, but your page is not unless is deployed. So apart from the source code navigation, we have event listener properties. Now, the interesting thing about this panel is that the event handlers are sorted in a capturing and bubbling order. So they are displayed exactly as the rendering engine is going to propagate events through it. That's what you can see on the screen when you bring it up. Now, let me mention that console is also a very powerful tool, especially in combination with the elements panel. So I undocked the developer tools window again and press escape to bring the console up. Now, in the console, we do support the command line API that is called the Firebug command line API. And it includes things like shortcuts for currently selected elements, and that's the $0, or previously selected element, it's a $1. I can dump properties of a selected node, and I can expand it in here. Or I can navigate my UI to a particular element. I can monitor events, and you can see a nice code suggestion here that are registered to a particular node. So all of these are part of the Firebug command line API. And you should make sure that you know how it works, because it's very useful. I think that's all what I want to tell about the elements panel. And with that, let me move to the next one, to the resources panel. I'll be demoing it on the Gmail side. So let me navigate to gmail.com real quick. And let's see what we have here. Now, the resources panel. Resources is something you're spending your time when you're dealing with network. All the network requests against your web server are going to be registered here. Let's try to explore what happens when we are navigating to gmail.com. So the first entry here is gmail.com, and it only has headers available, and we can see that is a redirect. We can see a 301 moved permanently, and all other response headers. And we've been redirected to the mail.google.com/mail. Well, it turns out that the second one is also a redirect. It is 302, and the reason for that I had missing cookies, so I was not logged in. And I'm being redirected to a login page. Well, the next one is the service login page, and that's actually the first page that has been served with the content. I can see the content preview in here. I can, of course, see the headers for this page as well, and it's 200, so it was served okay. Now, talking about the previews, we will support previews for various MIME types, such as images, scripts, and styles, and HTML, and even web fonts. And we are going to provide you with a nice syntax highlighting there, too. Let me go back to the timeline view. Now the timeline is something we open by default, and that's the time perspective on the resource loading. You can see the latency here, so that's a semi-transparent part of the bar. That's the time we've been waiting for response from a server. You can see a solid part, and that's actually the time consumed for data to be transmitted over the network. And that's a timeline view to that. We also support a size-centric view to that. And those two different sizes are the cell size of a resource and the size of a resource transmitted over the network. And they are different because we are using gzip encoding. Now it's really simple. It has several sorting algorithms in here for size and several sorting algorithms for resources. We have some basic filters so that you could filter resources of a particular type, and that's it. It's very simple but very useful when you're dealing with the resources and latency and redirects. With that, let me move to the scripts. And in fact, scripts is for debugging, and we have a dedicated story about debugging. So I'm going to skip it right now, and I'm doing the same with the timeline and profiles. We're going to have a dedicated story for each of those. And it brings me to a storage. Now the storage panel is where you manage the offline content of your application. And offline content is for us HTML5 databases. We support those. It's a local storage, session storage, and it's cookies. So while we are on the google.com domain, let me show you the view of the cookies. You can sort them here. It's a complete detailed view. It's not what you're getting while calling the document cookies. It's a real complete view on the cookies as they persist in the cookie manager within Chrome. You can delete them from here too, and you can see the markers on the HTTP secure cookies and secure cookies too. Now the databases is supported as a SQL command line. We can show you the number of tables that exist in your database, and that's it. The local session storages are just the tables where you can edit things in place. I can actually show you the HTML5 database sample on the one of the nodes demo. So the nodes demo is one of the HTML5 database demos, the very simple ones. I bring it up, and I can see a table in the database list. I can select a table, and I will see its content. Besides, I can issue a query in here, and you can see a nice suggest. It even suggests me the table names. So I can do search queries in here. It'll report me if I have any SQL errors here with the detailed information of those. So storage is where HTML5 modern stuff is, and we are going to add even more here. We are currently working on support for app cache instrumentation in here. Now, going further to the audits panel. And the audits panel is something that we've recently added. It's a number of sanity checks that you're running against your page. We are currently checking your network for your page for being fine with the network utilization and web page performance. But those, it is based on the rules engine, and those rules are fairly simple. So we check whether you're not doing too many requests against the same domain, that you're not serving images from the domains with too much cookies, that you're using caching aggressively, etc. So I can actually run it against one of the pages. Let me dock it back and run it against the Google homepage. So it's reloading a page, and it is coming up with some hints for me that, for instance, I should be setting the cache aspiration or cache info for the images, or I should minimize my cookie sizes, because you've seen there are a lot of cookies on google.com domain, or there are unused CSS rules. So these unused CSS rules are probably these ones. They could have been lazily loaded. Now we've designed the audits panel to be extensible, and we want third parties to be able to contribute audit suites into that. And those audit suites could be random. It could be mobile readiness. It could be something related to the network utilization, something more aggressive that we are currently providing. So we are looking forward to your feedback on that one, and we are open to adding new stuff into them. Going further, and that's last panel, but not least one. It's a dedicated console panel. That's something our users were asking us to do for a long time. Before that, we were able to open a panel in the given context using an escape key. Now we can have a full-blown console functionality here. You can do multi-line entry using Alt-Enter. And And console is really a powerful tool. I find myself spending most of my time there. Now, that's it for the overview. It's real quick. Again, we'll be touching scripts and timeline and profiles a bit later. Once again, this is all available in majority of WebKit-based browsers, should they have developer tools enabled. Now we've talked about overview, and currently switching to a completely different thing. We'll be going through the development stories. And we'll start with the debugging, because I personally do debugging a lot. Let me start with a demo. I navigated to a KubeUI hover card component. That's a UI primitive from the Clojure JavaScript library. And what it is doing, it is providing enrich HTML tooltips for the elements. So I'm hovering my mouse over an element, and I can see a tooltip. I'm sure you find it familiar because it is there in the Gmail. Now, let me try and debug it. For that, I'm switching to the scripts panel. And I happen to know that the main functionality of this thing resides in the hovercard.js file. So I type hovercard, and I navigate to that file. Well, in fact, I even know where the interesting function is. It's somewhere around line 200. And let me set a breakpoint here, undock it, and let's talk about the UI that we have. Now, that's a debugging environment. And the center of a screen is your JavaScript file. And you can choose the JavaScript file you're looking at using the file selector. Now, I am currently on a breakpoint, and I'm having a stack to the right. And the stack consists of the frames. Now, these stack frames are the functions that have been called. So the handle event has called handle trigger mouse over, and that one has called trigger for element. So I can see the complete stack starting from the event handler. Now, all of these stack frames have friendly names. And if you look at this trigger for element function that we are currently in, it is an anonymous function. It has no name. But we know what the name is. And the reason for that is the function name inferring that we have embedded into the V8 JavaScript engine. Now, for each of these stack frames, we can see the local variables. Those are variables available within the function scope. We can see Clojure variables and global variables. Opening console will even suggest to you the names of these properties so that you can dump them. And that's the state of this object on this particular call frame. So you can really get a lot of information on a suspended state of your JavaScript engine. Now, let me release it from a breakpoint, give you an overview of the rest of the UI. So we have watch expressions here. You can enter a watch expression, and it'll be reevaluated every time you step through the execution. We have breakpoints manager, and that's about it. Let me stop on a breakpoint again and show you something else. And something else is the on-hover evaluation. That's something that we have recently added. It can render primitive values when you're hovering over them. It will also render complex JavaScript objects, and you'll be able to explore them on the fly. And for functions, you will see their bodies. Like in Clojure, UI is a namespace, and you can see all the classes in this namespace. But it's really a JavaScript, generic JavaScript functionality. Now, that's pretty standard. Let's talk about something new. Imagine that you've been debugging your application, and you came to a point in the UI where you know that something is wrong, and you'd like to fix it. What you currently do is you stop your app, you go to the sources, you change the sources, you deploy the app, reload a page, go to the same place in the UI, complete all the steps that you've done, and see whether it has fixed or not. Now, wouldn't it be great if you could just skip all of that and make the change in place at this very moment, right in the JavaScript engine? And in fact, we now support that. So I'm double-clicking on a line here, and it becomes editable. Let me revert the condition and check if the page is working. Well, I'm having no hover cards anymore. So the page has changed at runtime. Let me set a breakpoint and see what is wrong. So I'm hitting this line, I'm trying to step through it, and I'm returning from a function early. So something is wrong now, and the app is not working. Let me actually fix it back and do something more complex. I'm adding a line with a logging here. So I'll be logging the value of the optional parameter here. You see the nice syntax highlighting? So we did parse the source, and we've got a new content here. Let's see if the app is working now. Yes, it is back to life. Let's see the console. We're getting a console entries for the hover events here. So we are actually changing the page on the fly. Now, how does it work? Unlike other JavaScript engines, V8 is running a highly optimized machine code, even when you're debugging or profiling your app. So to change the code on the fly, we need to actually find the function object in the VM, patch the machine code for it, and make sure all the other objects are referencing the new function. If that function is a constructor, then all newly created objects are going to use the new code. Now, can you change the function while you're running it? Let's try it out. I'm standing on a breakpoint in here, and I'm doing yet another modification here, some safe one. So what has happened? I can't continue the execution of the function that I'm modifying, right? So what we do is we're kicking it from the stack and returning back in time to a point just before calling into that function. And that's the trigger for element. Now if I step into it, I will have a new body here with a 3 equal sign in here. So you can skip all the hassle and change your application on the fly, add conditional logging, add whatever you want into the function bodies, and see it work at runtime. You could also modify a function to get back to a place before the function call if you are debugging and seeing that something went wrong. So we find it pretty exciting, and it's just a preview. We are currently editing lines and blocks only, but the underlying V8 capabilities allow us to patch entire sources, do or bit changes to source code on the fly, and we are willing. Sorry, is it okay now? And we are willing to explore it. Now that's the debugging story, and we have something. Yeah? Check. Is it okay? Okay. So, and that's the debugging story, and we have added something new to it that we believe exists only in our app so far. With that, let me switch to the next story. And the next story is going to be about performance. Now we have our app working properly, and we debugged it well, but it might be slow. What do we do in that case? Well, what we do is we start profiling it. Let me open a Canvas DNA model and go to the Profiles tab and start recording. Now, while I'm speaking, it is capturing the stacks from the V8 execution and sampling them at a rate of 1,000 per second. When I stop, it will provide me with the aggregated information on that profile. Let's explore it in a bit more detail. I will start with the top view on the profile, and I can see here that in this anonymous function, the animate method has been consuming 96% of time while I was measuring. Now I can explore it further and see that it has been rendering something, and it has been mostly drawing lines and points. Now for each of those, I can dive into source and see what's happening there. Some of those, though, do not have source lines associated with them. Let's find out what are these functions. Well, in fact, these are the functions begin path, move to, line to, and these are native functions defined on the Canvas context. So they are native, they are implemented by a browser, and you can't really optimize them. However, you can see what percentage of time or milliseconds of time they are consuming, and you can minimize the number of calls into them. Now, these functions are native. They can even be not functions, but setters, but we are still capturing the amount of time that has been spent there. I can switch to the heavy view, and heavy view is just a flat view when functions are sorted by the self-time. So the more expensive ones get to the top, and we can see here that the most expensive ones in this demo is fill, stroke, style, stroke, so we can't really optimize the canvas rendering of the DNA, but we could cache some strokes, cache some styles, reiterate over cycles, and do something there. So that's our profiling story, but that's a JavaScript profiling story. And JavaScript is not the only thing that is happening inside of your browser. There are other CPU-expensive operations consuming memory and such. And those operations are calculating CSS styles, primarily, dealing with network, repainting fragments on the screen, refloating your page. All of these things are taking time, and we have a tool to capture that. And this tool is called Timeline. Let me show you how it works. I'm docking developer tools back, and we'll be exploring a search result. So I'm looking for purple flowers. Let me start recording and reload page real quick and stop recording. So the Timeline UI. You have an overview on the top with the three major categories of events that are happening inside your browser. These are loading, scripting, and rendering. And for each of these categories, you have detailed record list at the bottom. I can zoom into an area of interest using an overview panel. I just dragged it, and I can see what has been happening in this time frame. Now I can see several send requests. I am seeing several event dispatches. I'm seeing Pane events and even garbage collection events. Now, how do we do that? Well, in fact, we added a lot of native instrumentation into the WebKit rendering engine, into the web core, and we are propagating that information and visualizing it by means of the Timeline front end. Now, if I expand this evaluate script that has been happening on google.com, so we were searching for purple flowers, the script has been downloaded, it has been executed. The execution has actually taken about 50 to 70 milliseconds. Now let's see what was happening inside that script evaluation. And we can see a number of style recalculations happening here. Unfortunately, navigating to a minified source won't give us much information, but we know that they've been happening here, and we know that we could optimize it. For instance, we could do some primitive optimization, such as remove an object from a render tree, make some changes to it, cache them, bring it back, so that the style was recalculated only once. In this case, we can see that it has been calculated several times, and some of them were taking actual time and CPU. Now, we've built this tool primarily for the performance analysis. However, we've learned that it is a great tool for learning what your program is about and how it is functioning. And let me show it to you. I'll be showing it on the ZP example, and ZP is another closure component that is implementing the animation of expandable compartments in a cross-browser manner. Now let's try to find out how it works using the Timeline panel. For that, I'm starting recording, and I'm doing a single expansion, and I'm stopping recording. So let's explore it. There are random events, and I can see a single large event click. Let me expand it. So I clicked a ZP header. What happened? It called a function. What that function did, it installed a timer in the register animation. And upon fire, this timer called cycle animations. They can see that the cycle animations method is its first line removing the timer, and is its last line re-adding the timer. Aha, so we are seeing a recursion here based on the timers. And that's essentially what you do when you want to make a cross-browser animation. Now let's see what it ended up with. We're scrolling down for a second or something, and we can see a latest entry that is clearing timeout in the unregistered animation, and that's where the animation stopped. Now let me remove all the unnecessary info. I'm putting up a filter that removes all the events less than 15 milliseconds and collapse it. Now what has happened from the bird's view is just a single event click. And in fact, if you were using classical JavaScript debugging and other techniques, it would tell that the event click has taken 0 milliseconds because that event click was not processed anyhow other than setting up a timer. However, it has implications that were happening for a second. Your browser was calculating something. In fact, it was not only doing JavaScript, it was also recalculating styles so that the expandable compartment was animating. Now, how do we do that? those timers were happening asynchronously, and we are capturing them all under a single event handler umbrella. So what we do is for all the asynchronous events in the browser, we bind them together. For instance, the timer fire will be bound under the install timer, so that you knew that the timer fire has been caused by the timer install. And we do the same for resource loading, and we do the same for XHRs, so we can track really complex control flows that are happening asynchronously in your page through that. And in fact, if I collapse it back, you will see that, let me go back to the google.com page with the results. You can see that some of these were actually happening simultaneously, which is kind of impossible since the JavaScript is single-threaded. Well, the reason for that is we are tracking not the synchronous execution time, but we are tracking the causation analysis. And if you implement a kind of a control flow based on timers, you could actually have several processes happening at the same time. One process was polling the server for notifications, and another was redrawing something. So that's our performance and understanding your code story. It is primarily based on the profiles and timeline panels. And with that, we now know how the page works, and we know that it is working fast. We even know that we are beyond JavaScript checking the native performance of the application. However, it is not enough. Even if your program is correct, even if it is fast, if you have a memory leak, sooner or later, it'll start lagging or even make browser do strange things. So you need to understand how is memory behaving in your web application. For that, we have a memory profiler. I'll be demoing it based on the hover card demo. I'm switching back to the profiles panel, and I'm clicking this eye that is taking a snapshot of my heap. Before I explain what it means, let me move my mouse around in here and take another snapshot. Okay. So the heap. You have a lot of JavaScript code running inside your app, and this JavaScript code is creating a lot of objects. And these objects are having references to each other. So they are retaining the other objects and preventing them from being garbage collected. Now what we have here is objects in your heap aggregated by their class. V8 allows us to understand that that's a class of a JavaScript object. So we have code objects in here, some arbitrary objects, closures, strings, arrays, and we have size in bytes occupied in the JavaScript virtual machine. Now we have 95 arrays here. Let me expand it. What it shows when I expand the node is the classes of the objects that are retaining arrays. So what this picture is telling me is that there have been 95 arrays created in the app. And there are objects of these types, DOM window, simple pool, map, logger, etc., that have references to these arrays and prevent these arrays from being collected. I can expand further, and sooner or later, I'll go to the garbage collection root or a global property. So if you store a reference into a window object, it'll be there forever, and the property will be preventing the object from being collected. Now I've taken 2 snapshots, and I've done something in between. And let me show you what it tells me. I'm doing a diff between these 2 snapshots, and I can see that the snapshot that has been taken after has 46 more elements of type div element, has some more strings, etc. Let's try to see who is retaining those. Okay, so these are objects of type div console and hover card. And these are objects that have references to these new divs, preventing them from being collected. Let's try to find out in the UI what are these 46 new objects. Well, in fact, that's this event log that is growing when I'm moving my mouse. So that's the classical scenario of evaluating your memory, fighting the memory leaks. You do something, you take a snapshot, you do something, you take another snapshot, you compare those. If you think that no new objects should be retained, it should have 0 differences. If you want something to be collected, it should be negative. So that's our memory story. It's also pretty unique to the V8 rendering engine and JavaScript engine. And with that, are we talking about internal design? No? Okay. We're skipping the internal design unless you guys want to hear about the internal design. Okay, we can spend 2 minutes. I'll do it real quick. So before the internal design, the process of development. We are implementing Chrome, right? But we are also contributing to V8 and WebKit to make this functionality available. So we're all WebKit committers, reviewers, etc. Now, these are all open source projects, and they're all combined together. The way they are combined is on a daily basis. Chrome is picking up the tip of the tree of a WebKit browser. Then we regularly pick V8 as well, roughly twice a week. What it means to you is that we are having a nice integration builds pretty much on a weekly basis, and they are available on the dev channel. So if you're web developers, and if you want to have latest and greatest of developer tools, you should stick with developers channels. They are fairly stable, at least for doing your web development, and they have a lot of tools there that might be missing in the stable or beta. Now, talking about the internal design itself, the majority of code, source code, is in the WebKit, and it basically has a backend and a front end. And the front end that we've been seeing here, well, you know what it is implemented with. What do you think it is implemented with? This UI. Is it 2 options here, 3 options? So HTML5, native, Python, yeah. Anything else? So, yeah, right. So it's HTML, JavaScript, and in fact, you can even inspect it by its own means. So you just inspect element on one of the front-end objects, and you see it running. So that's just the web app. The front-end to the right is just the web app. It is talking to a backend over an IPC in Chrome. So it is crossing the process boundary, making requests, getting responses, and this transport is implemented on the Chrome level. Now, we like it because it allows us doing remote debugging as well, and that's something actually that we are currently working on. With that, back to Anders.
Yeah. Thanks very much, Paul. So just before we wrap up, wanted to give you a few pointers. The main place to go if you want information on the developer tools in Chrome is on the chromium.org site, chromium.org/devtools. There's videos showing you how to get started. There's a full tutorial and so on. And as Pavel just has explained a bit about the internal design and how this is all open source, parts of different open source projects, we very much encourage you to contribute either through feature requests. The place to go is the Sierra bug, or if you want to file it directly in WebKit, there's a URL for that as well. Or if you have questions about the inspector or the developer tools in Chrome, there's a recent RSC channel as well. There'll be people there. It's my experience pretty much around the clock. There's people sitting here in California working on the inspector, and obviously Pavel and his team in St. Petersburg is also there. So please go and check it out if we manage to get you interested through the session. That's it from our side. Thanks very much for showing interest, and I hope you found some of this exciting. There's still time for questions. If any of you have questions, we're happy to try and answer them. So thanks.